Welcome to the Xpediter TSO Testing Basics module. Here you will learn the fundamentals of running an Xpediter TSO interactive testing session. The various commands are powerful yet simple to use, allowing for efficient testing sessions. A typical job is run by submitting execution JCL to the operating system. Normally, all goes well and 0 return codes are issued. Sometimes, though, there are problems and a job crashes. We all know that feeling. When we need to know what really happens during program execution, Xpediter is the best option. With Xpediter TSO, you give it the execution JCL. In turn, you get the keys and you are in the driver's seat. The next thing you know, you are at the beginning of the program. You may recall this as the final point shown in the setup module. Before stepping on the gas, we are going to clear the before breakpoint message at the top by pressing Enter to discuss the layout of the testing screen. Across the top, you will find the program name, load module name, and the compile timestamp. These should always be reviewed to make sure you are testing the correct program. Much like an editor, primary commands are entered on the command line and line commands are entered at the left. The current execution line is indicated by an arrowhead and by highlighting the text on the line. Although it resembles an editor in appearance, your code is safe and cannot be changed here. Recall that it is displayed from the DDIO file that was created at compile time. I know you are anxious to begin driving, but there are 3 final navigation items to review first. Scrolling and the scroll amount is like the editors, with function keys 7 and 8 normally set for up and down. Here we set the amount to maximum and press F7, taking us to the top of the program. The primary command locate asterisk will always return the view to the current execution point. F6 is normally set for that command. Finally, when it may be convenient to hide some lines from view, the exclude line command is available. Here, the block format is shown, as is the result. Driving a program requires some knowledge of the available Xpediter commands. Next, we will look at some of the common questions about driving and see which commands may be used to answer each. How do I run the program? How do I stop the program? How do I comment out or at least not execute certain lines of code? How do I change the execution path of the program? How do I examine memory to see what values are driving the logic? How do I change memory without changing the input data? And finally, how do I do what? We will look at some additional commands. We will begin by reviewing the commands used to run the program. The first is the go primary command, which has 2 commonly used variations. Go n causes the program to execute n number of lines from the current execution point. Examples would be go 3 or go 9. The unconditional go causes the program to execute from the current execution point. The program will stop when one of 3 things occurs. either a breakpoint will be encountered, or the program will end, or the program will crash. The final item in this group is the run to N primary command. The program will execute from the current execution point and go as far as the requested line without stopping. Breakpoints are honored. Let's look at some examples. In this example, the current execution pointer is at line 652. We then enter Go 3. 3 statements are executed, and the current execution pointer is now at line 655. Next, we look at the 3 possibilities that may be seen with the unconditional Go command. Here, the current execution point is at line 652, and the Go command is entered. We next see that a breakpoint is encountered at line 658. Next, we are positioned at the beginning of the program, and the Go command is entered. We then see the test completed message, and we are at the end of the program. For the last example in this set, we are again positioned at the beginning of the program, and the Go command is entered. We then see that the program has crashed at line 403. Finally, we are positioned at the beginning of the program, and the run to 361 command is entered. We then see the breakpoint encountered message, and we are positioned at line 361. At this point, we will review the commands used to stop the program. The discussion begins with breakpoints, some of which were seen in the Go command examples. Breakpoints halt program execution and return control to the user. They may be installed and removed at any time. We will look at before breakpoints to halt execution before a specific line, after breakpoints to halt execution after a specific line, and the when and count conditional breakpoints, which cause execution to halt based on conditions in the program. As shown previously, testing begins at a before breakpoint. The before and after breakpoints shown are automatically set by Xpediter. The before gives the initial control to the tester, while the after allows the tester to decide when to pass control back to the operating system. We will now look at how the user sets and removes breakpoints. Breakpoints, whenever needed, may be set by using either primary commands or line commands. Here we see 2 different ways to set the same before breakpoint. The primary command is B followed by the line number. The line command is simply the letter B. The adjacent space is not necessary. It makes it easier to see the line command. Upon applying either command, we see the message and the breakpoint has been set. Here we see the block form of the line command followed by the result. Here we take you through a sequence of setting an after breakpoint on line 353, then viewing the result, then setting a before breakpoint on the same line, then viewing the resulting @ symbol indicating that before and after breakpoints are set on the same line, then showing the 2 different ways, primary command and line command, to delete the before breakpoint on that line, then viewing the result where only the after breakpoint remains. Here we see one of the two conditional breakpoints mentioned previously. The primary command count 630 maximum 20 establishes a number of executions counter on line 630 and sets a breakpoint when that value reaches 20. That counter, shown here, is visible to the tester as the value changes. The other conditional breakpoint is the when condition. In this first example, the records read program variable is continuously evaluated. Program execution will halt if its value reaches 50. Similarly, the two program variables encircled are continuously evaluated. Program execution will halt if north count is greater than south count. In this final case, the east count program variable is continuously evaluated. Program execution will halt when its value changes. You may have noticed that setting a when condition leaves no visible evidence. In order to see the when conditions in effect, we must use the show when command. The results are shown here. Deleting an active when requires only a simple line command on this screen. The results are shown here. A common testing technique is to comment out lines of code to bypass their execution. While we cannot actually comment out lines, we can use the skip command to accomplish the same goal. Both primary and line commands are available. We will go through a series of installing and removing various examples of skip commands. We begin with showing how to skip line 355. Similar to the breakpoint command shown previously, either the primary command or the line command may be used. Here we see the result. Next, we see the primary and the line command for skipping multiple lines, followed by the result. Next, we will see three ways to delete skip commands. First, we see the block delete. Then we see the single delete line commands. Then we see the delete primary command. The delete command may be used to delete most Xpediter commands. For the final skip example, we see skipped lines that are close and visible on one screen. You may have skipped lines throughout the program. To view them more conveniently, we may use the show skips command. Here we see the result. Skipping lines does not really change the execution path of a program because the lines that are executed are still done in order. A true change in execution path may be achieved by using either the goto primary command or the gt line command. Caution: be extremely careful when changing the execution path. While it is suitable for testing isolated sections of code, once the path is altered, you may have lost your way back. Internal pointers showing the preceding execution path are not saved. Simply running the program after a path change may yield unpredictable results, including abend or program termination. Here we see the primary command to transfer execution to line 361. The line command to do the same thing is simply the letters GT on the appropriate line. Here you see the resulting message, and the current execution line is, as usual, highlighted. Remember that this is not like the run-to command discussed previously. Preceding lines are not executed. A go-to is an immediate jump to the indicated line. It tells Xpediter, stop whatever you were doing, just start here. Examining the contents of memory is easily done. Keep has both primary command and line command formats. The same is true of peek. Using keep, program variables are placed in a reserved window and are available for continuous observation as values change with program execution. Using peek, the values of program variables are observed as needed by viewing program code in the definition area. We will look at several examples. We begin at the view shown previously at the beginning of a program ready to test. In order to demonstrate the keep command, we must reopen the keep window, which is, by default, open and set to 5 lines. We can assume that it had been closed during a previous testing session. We use the set command to re-establish the keep window. Here we see the result. The keep window appears, and the source code window size is decreased by 5 lines. The keep window itself is resizable. When many variables are kept, the contents are scrollable as well. With the auto keep feature, variables referenced in the current execution line are automatically displayed in the keep window. Here, the current execution line contains one program variable, parm_info. That also appears in the keep window, along with its current value. As program execution continues, the keep window contents is continuously refreshed with the changing values of both auto-kept and user-kept variables. In this example, the current execution point is at line 403, and the corresponding variables appear in the keep window. The first variable, empWages, has no value because the compute statement has not yet been executed. In order to retain these variables in the keep window, yet complete the computation, we use a variation of the go command, go_half, abbreviated as go_h. Here we see the result. The value of empWages has been computed. The current execution pointer now has a double arrowhead, indicating that execution of this line has occurred. In this example, the K3 line command is used to keep the third variable on the line, counting from the left. Here we see the result. The variable appears in the keep window. The K prefix indicates that the entry is user-kept and will remain until deleted by the user with the delete command shown previously. The same variable appears below, the result of auto-keep, as it appears in the current execution line. Here, the P2 line command is used to peek at the second variable on the line. The result is shown here. Notice that the keep window did not change, but the program source window scrolled up to the definition of the variable. The current value will always be available, but the user must scroll to the proper line to see it. In this example, the PE line command is used to peek at the elementary level variables in the structure. The results are shown here. In this example, the peek hex line command is used to see the hexadecimal value of the variable. The result is shown here. Finally, in this example, the keep hex line command is used to keep the variable and display its value in hexadecimal. Note that the keep command has been entered on the line where the variable is defined. The result is shown here. In addition to viewing the contents of memory, it, of course, makes sense to change the contents of memory as well. This may be done by simply overtyping the value or by using a move command. We will look at some examples. Here we see that one of the variables in the keep window has the value of 30. We overtype the value, changing it to 123.45. Although the move command shown may appear to be a less convenient way to change the value, it may be used at any point during the testing process. In other words, the user need not enter a keep or peek command prior to changing a value. The result is shown here. At this point, we will look at some additional facilities. The first is a variation on the count command seen previously. Second, the browse command allows viewing an input file during testing. Finally, the function key settings are customized for testing efficiency. We will have a closer look. We begin this example by setting a counter on line 630. Either the primary command or the line command may be used. Here we see that the counter has been set. Next, the program is run to completion. Returning to line 630, we see that this line has been executed 19 times. Here we see the primary and line commands that could be used to establish counters on a set of lines. Here are the results. Counters may be deleted using the routine primary or line delete commands. For this example, we are at the beginning of a new test. We establish counters on 4 paragraphs. We then run the test to completion. To examine the counts without scrolling, we use the show counts command. The results show that the paragraphs had different execution counts. As noted on the screen, end will restore the source code view. At times, it may be helpful to have a quick look at one of the files used during a testing session. The browse command, shown here, provides that capability. Emp file is the DD name for the file that was allocated for this test. The result is shown. When using Xpediter, your standard ISPF function key settings are in effect until you enter a testing session. At that point, Xpediter takes control of those keys. To view and/or change the testing settings, you may choose option 0.1 from the Xpediter primary menu, or use the keys command from within a testing session. Here you see the default settings for the first 12 keys. Using keys 6, 7, and 8 was mentioned previously. Since Go 1 and Go are commonly used, keys 9 and 12 are assigned those values. Another convenience is the peek cursor value assignment. To peek at the value of any variable, simply place the cursor anywhere on the variable name, anywhere in the source listing, and press F2. We will now go through a sample testing scenario. A normal program run has crashed. We are going to test the program with Xpediter. We would like to identify the point of the crash, as well as the reason for the crash, and then allow the program to continue if possible. We launch the Xpediter test and enter the program at the beginning. Knowing that the program will crash and wanting to identify when that occurs, we put the records read variable in the keep window. Prior to execution, the value is 0. We then run the program. The program crashes and the records read value shows that we are processing the 4th record. We crashed at line 403 a compute statement. One of the variables involved contains invalid packed data. To investigate further, we peek at the hex value of this variable. That is shown here. Several alternatives are available here, but the goal is to get the program running. We overtype the invalid data with 12.50. Pressing Enter shows the new hex value, and the new value also appears in the keep window. We enter the Go command to continue execution. The program ends successfully and the final record count is 19. The sample testing scenario is complete. When testing, keep in mind that running a program is real. Records are read, and records may be written, updated, or deleted depending on the program logic. As was noted in the Setup module, several publications are available on Frontline. You may find the Quick Reference Guide especially helpful. Also, a Helpful Hints document may be downloaded by clicking on the Attachments tab at the top of the screen. This concludes this module. Thank you.